Let's do another example problem. Chapter 10, Section 2, example problem. We are given an op amp, okay, and the input voltage is given to be that guy, okay. We are supposed to calculate the power dissipated in the 1 kilo ohm output resistance. So really, we are interested in finding out the output voltage V0 and the output current I0. Once we know the V output and output and I0, I output, okay, or IO, I output, we can simply multiply VO and IO and get the um, instantaneous power, and then um, we can get all the parameters of interest, P average. So let's go about calculating I0 and V. How do you do that? First of all, I'm going to look at the 80 microfarad capacitance. For the 80 microfarad capacitance, the impedance of this capacitor, which is in the feedback path, is minus j over omega c. That is minus j over omega is given to be 5000 and c is given to be 80 nano. So this comes out to be minus j 2500 ohms. Okay. Now the next thing we can do is notice that the 80 ohms or 80 microfarad, which we evaluated to be negative J 2500, is in parallel with 7.5 kilo ohms. So if I evaluate the impedance of the feedback path, what is the impedance of the feedback path? The impedance of the feedback path really is ZF is nothing but um, the parallel combination of 2500 negative J and 7.5 kilo ohms. So the product of those two things, really 7500 into negative J 2500 divided by 7500 negative J 2500. Okay, so that's going to come out to be 2371.7082. I'm going to have to move some terms here. Okay, 7.82, 7082 angle negative 71.5651 degrees volts. Okay, so that's the ZF. Oh, it's ohms. Thank you. 71.561 ohms. Now we can calculate VO. How do we calculate VO? Well, notice that this op amp is in negative feedback configuration, right? In the negative feedback configuration, we simply know, go back to your op amps, V output is nothing but negative VG times ZF over Z in. Okay, ZF, we just calculated the impedance of this guy, and Z in is nothing but the impedance 1.5 kilo ohms. So let's solve that problem. ZF is this guy 2371.7082 angle negative 71.5651 ohms divided by the the impedance looking in is 1.5 kilo ohms, so that is 1500 angle 0 degrees. So all of this V output therefore comes out to be 6.3246 angle negative 71.5651 degrees. Um, and it's in volts. Okay, everybody get this? All I have done is to apply the formula for inverting amplifier. I notice that the op amp is in inverting configuration. Therefore, V output is all of this guy. And what did I miss? I may have missed in here the expression, the value 4. Okay, 4. What's that? VG. VG is given to be 4, right? Now, let us see. So, this is all negative. Okay, so you will see that, so that 4 is coming from here, 4, um, and then don't forget the negative sign there. Okay, so V output will come out to be 6.3246 angle 71.561. How do you calculate I output? I output is nothing but, so if you know the voltage across this, okay, across this resistance, you can simply divide the voltage by the resistance. So V output over 1 kilo ohm, that should give you I output. So this is going to be 66.3246 angle negative 71.5651 degrees divided by 1 kilo ohms. So this is going to be in milliamperes 63.246 angle negative 71.56 milliamperes. Okay, so now we know V0. Now we know I0. So let's write out V0. Okay, V output is nothing but 6.3246 cosine omega t, was omega t given to be 5000, 5000 t minus 71.5651 degrees. Similarly, sine I0 is going to be 63. Is it 63.246 cosine of 5000 t minus 71.5651. This guy is in volts. This guy is in milliamperes. Okay, so you can plug that milli and just say to the 10 to the negative 3. Okay, or you can carry forward that milli. Now we are asked to calculate what? We are asked to calculate the P average dissipated by the 1 kilo ohm resistance. So P average is our very familiar form Vm Im over 2 cosine of theta V minus theta I. Something really interesting happened here, as you will see in a minute. 6.3246 into 63.3246 milli by 2. Okay, so all of this is going to come out to be 20. Let's see what happened here is, remember cosine theta V? Cosine of theta V is the same angle um, as theta I. So this is going to be 0 degrees. Cosine of 0 is 1. Okay, so this comes out to be 20 milliwatts. So 20 milliwatts is being dissipated in the output resistance. So that is the answer that we are after. Okay, so let's retrace our steps. We started with an operational amplifier. In order to calculate the output voltage, we applied the inverting configuration formula. Once we calculated the V output and I output, from there it's a pretty straightforward path to calculate V average.